let's dive into one of those questions that everybody wonders about at some point. Can you actually hear anything in space? You know the line, right? It immediately brings up this image of a cold, vast, and totally silent universe. But is that the whole story? Yeah, this tagline, it's from the classic movie Alien. And let's be honest, for decades, this basically became scientific fact for most of us. The accepted wisdom was simple. Space is silent, period. So you get this epic pop culture face-off. In one corner, you've got Alien, sticking to the laws of physics with its terrifying silence. And in the other, you have Star Wars, with those iconic TIE fighter shrieks and booming explosions. It's realism versus awesome movie magic. So which one really got it right? To really get to the bottom of this, we first have to ask a more basic question: what even is sound? So let's do a quick dive into the physics to understand why space has this reputation for being so quiet. Okay, so at its heart, sound is a type of wave, specifically what scientists call a longitudinal wave. Now that sounds complicated, but all it really means is that the wave's energy pushes particles back and forth in the same direction that the energy is traveling. And this is the perfect way to picture it. Seriously, think about pushing a slinky. You see that bunched up part? That's a compression. That travels all the way down. And right behind it, the coil stretches out. That's a rarefaction. Sound does the exact same thing, just with molecules in the air instead of slinky coils. And right here, this is the absolute key. For that pushing and pulling to happen, the sound wave needs stuff to push and pull. It needs particles. It needs a medium, whether that's air, water, or even a solid piece of metal. So the logic is simple. In the vast emptiness of space, there's basically nothing to vibrate. No medium, no sound. Case closed, right? Alien was correct? Well, not so fast. And this is where it gets really, really interesting, because it turns out that whole empty space thing isn't entirely true. You know, this is a question that comes up all the time. People think, wait a minute, what about all that stuff in space? Those giant, beautiful clouds of gas and dust you see in pictures. Couldn't sound travel through them? And the answer is, yeah, technically it can. Sound waves can travel through those gas clouds. But here's the wild part. The particles are so incredibly far apart that the sound waves they create have wavelengths that are literally miles long. The frequency is so low, our ears would never ever be able to hear it. So you still can't hear a scream, but the fact that sound exists at all out there opens up a whole new door. So if we can't use our ears to hear in space, what if we found a different way to listen? What if we could take all the amazing data our telescopes collect and turn it into sound? Well, there's a name for this, and it is so cool. It's called sonification. It's the process of translating information, any kind of data really, into sound. And NASA is using it to explore the universe like never before. So how on earth does this work? Well, it's pretty straightforward, actually. First, scientists grab all this data from telescopes, things like light intensity, radiation levels, you name it. Then they get creative. They assign musical rules to that data. Maybe a brighter star gets a higher pitch, or something on the left of an image gets panned to your left earbud. And finally, they generate an audio track that is a direct, one-to-one translation of that cosmic data. And to give you a sense of the sheer scale we're talking about here, just look at this number. To make the sound of the Big Bang audible, scientists had to raise the frequency by a factor of 10 to the power of 26. That's a 1 with 26 zeros after it. I mean, it's just a mind-bogglingly huge number. And this right here, this is the actual blueprint. This squiggly line represents the faint, leftover heat from the Big Bang. It's basically the universe's first baby picture. And scientists took every little bump and wiggle on this graph and turned it into a note, creating a symphony from the very first moments of our universe. So the Big Bang is one thing, but what else is on the universe's playlist? It turns out scientists are building a whole library of these cosmic sounds. I mean, we can actually listen to the data from the Voyager probe as it finally left our solar system. You can hear the complex, layered structures inside the Crab Nebula, the remnants of a star that exploded. You can even hear a soundscape made from Hubble's famous cosmic reef image, translating starbirth into audio. It's amazing. And you might be thinking, okay, this is neat, but is it just a gimmick? And the answer is a huge no. This is a powerful scientific tool. Our ears are incredible at picking up subtle patterns and changes over time. things our eyes might just glance over in a chart or a static picture. This is actually leading to new insights and discoveries. And, maybe the most important thing about all this is how it opens up the cosmos to so many more people. For astronomers in the blind and low vision communities, this provides a profound, direct way to experience and analyze data that was once off limits. It makes space truly more accessible for everyone. NASA really hits the nail on the head here. They say sonification provides a whole new way of experiencing and thinking about data. It's not just about listening to space, it's about understanding it in a totally new dimension. So at the end of the day, that classic tagline was only half right. You can't hear a scream in space, but it turns out space is full of music. We just had to learn a new way to listen. And it just makes you wonder, doesn't it? With all the new telescopes coming online, what other cosmic symphonies are out there, just waiting to be heard?